Okay, so we left off last time. We were talking about how to factor harder, more difficult trinomials, right? Trinomials where of the form ax squared plus bx plus c, where a is not equal to 1. That makes them a little tougher, right? So this was our recipe for dealing with functions like that, right? Let's walk. And so I'm going to leave this here for your notes, but let's look at the example where we kind of left off here, right? We had this quadratic trinomial, ax squared plus bx plus c, where a is 9, b is negative 12, c is 4, right? So our strategy, and this is consistent with, you guys learned bottoms up, I think, probably in algebra when you did this stuff, right? A lot of this is consistent with that. And I'll remind you how to do bottoms up. A lot of times now we call it slip and slide instead of bottoms up, but this is a better way. The way I'm showing you now is really the best way to do it. So we want to find magic numbers, right? The magic numbers, they have to be factors of AC. So they have to multiply to A times C, which in this case is 36, right? 9 times 4. And they have to add to negative 12. Well, the numbers that do that, you guys figured that out. That was negative 6 and negative 6, right? Would add to negative 12 and multiply to 36. And remember to play what I call the sign game there. If the two magic numbers are multiplying to a positive, what does that tell you about the two numbers? What are the possibilities? If I know that they're going to multiply to positive 36, what does that alone tell you about the signs of the two magic numbers? Just type it in chat. How about? The fact that the two magic numbers multiply to a positive, what does that tell you about their signs? There's two possibilities. They're both negative or they're both positive, right? If we're only considering that part of it, the fact that they multiply to a positive, but the fact that they add to a negative tells us that they both must be negative, right? Because they're adding to a negative. So that if we just take that second and think about the signs, that's always a little bit helpful. So we know we get two negatives and they're negative 6. So then what we do is we're going to use those magic numbers and we're going to replace the negative 12 with a negative 6 plus negative 6, right? And so we're going to split that into a negative 6x plus a negative 6x, okay? And that gives us, instead of the 3 terms in the trinomial, that turns this into a 4-term expression, right? And then we can split this down the middle and we can factor by grouping. And let's just review the steps in factoring by grouping. And you might be thinking, I wouldn't blame you if you were, you might be thinking, well, this sounds like more work. But here's the thing about this. When we factor polynomials later on in the class, when we factor bigger polynomials that involve an even number of terms, the way I'm sorry.
I couldn't hear you for a second.
Oh, really? Okay. Here, let me backtrack a little bit.
It might kind of glitched out for a second.
Oh, really? Huh. Does it sound okay now? Okay, let me backtrack just a little bit. So what I was saying is, even though was I talking about how you might think this is more trouble than it's worth? It might seem like extra work okay. But the thing about it is, this is the technique that you're going to use, this grouping technique. Factoring by grouping is what you're going to use when we move on to more complicated polynomials that have more terms to begin with, right? When they're not just quadratic, maybe they're cubic or quartic or, fifth degree polynomials or something like that. If you have an even number of terms, one of the techniques we can use to factor is grouping. And so this is something that, this is a really common thing you're going to be doing in your future anyway, okay? So then after we've grouped these, we've split this middle term by its magic numbers, then we focus on the first group of 2. So the 9x squared minus 6x in this case. And we factor out the greatest common factor, which is a 3x. And then we determine what the remaining binomial is, right? After we factor out the GCF, we're left with a 3x minus 2. Now, we know that if we were able to find magic numbers that worked, this is guaranteed to work every time. So then we automatically know that we can get the same binomial, we can have a common binomial factor in both of the two groups, right? That when we've grouped it into, the first group and the second group, we know that we can factor the second group in a way so we get the same binomial factor, and we have to do that. We have to have the 3x minus 2 has to be our binomial factor in the second group. And so then the last step is we just figure out, well, what do we have to undistribute from the second group to make that happen? We factor out a -2, and it works. And now I've got two groups, right? I've got two terms in this. The first term is 3x times the quantity x minus 3x minus 2. And the second term is -2 times the quantity 3x minus 2. Each of those two terms now has a common binomial factor that we can undistribute, right? So I could factor out the 3x minus 2 from each of the two groups, so it goes out front. And then what's left behind from the first term is a 3x plus -2 from the second. So I just end up with 3x minus 2 is my other factor, and I'm done. See how that works? I'm sorry? Say that again, Maria. I missed that.
Is it a coincidence that they're both the same?
That the -6, you mean?
X minus 2.
Oh, no, that has to always be that way. That has to be the same.
But like the final answer.
Oh, yeah. Oh, I'm sorry. Yes, it is. It is a coincidence. Yeah, it is. The reason it's a coincidence, and I bet you can guess why. Because the magic numbers, here's why, because the magic numbers were the same in this case. Okay, so it turns out that 9x squared minus 12x plus 4 is what we call a perfect square trinomial. Okay, and we can actually kind of see that pattern because it fits, and I don't want to go into too much detail on this, but if you want to know how you could see that right away, look at the pattern here. It fits the pattern, ax squared plus bx plus c, where the middle term is equal to, if I write the first term as something squared, it's the quantity 3x squared, right? And the last term is the quantity 2 squared. Well, the middle term is just, it's a minus 2 times the quantity 3x times 2, right? If that doesn't make sense, don't worry about it. I mean, that's we don't really even need to see that. It's more trouble than it's worth. If you're interested, you could go back and maybe I'll hit this later. I don't want to clog up what we're doing now with an additional concept that's not really important or related. But I'll come back to that idea later when we're doing something else or between concepts. Let's practice this again, though. Let's try another one. Something like this, how about? Okay, first thing we always want to do is we want to ask ourselves, you tell me, what do we always do first when we're factoring? What do we always try to do first?
See if there's a greatest common factor.
Yeah, factor out a greatest common factor. Can we do that here? Yeah, is there a GCF I can factor away from everything? 3, there you go. I could factor out a 3. Good. So the first step is going to be we can factor out a 3, and then we're left with the trinomial, 6x squared minus 7x minus 3. Okay, but now we're still stuck with a quadratic trinomial where a is not equal to 1, right? Let's write down our values up here. So we have an a value of 6, b is -7, right? And c is equal to -3, okay? So we're going to have to, if this factors, we're going to have to factor it, using our grouping technique here. We'll know right away if it factors if we can find magic numbers. If we cannot find magic numbers, it doesn't factor conveniently, okay? So are there magic numbers? They have to multiply to AB. So what's the product of A and B here? Say it out loud, somebody.
Isn't it A times C?
Oh, sorry, A times C. What am I doing? Gosh, yeah, A times C. Whoops.
And that would be 18.
And it's -18?
Yep.
And B is equal to -7. So our magic numbers have to be factors of AC, right? So they have to multiply to -18 and they have to add to -7. So let's make a list of our magic numbers here. We'll call our magic numbers, we'll just call them M and N, how about? Let's play the sign game. If they multiply to a negative, what does that tell us about the signs of our magic numbers? Yeah, they're opposites. Good. Now they're opposites, and if they're opposites and they add to a negative, which is bigger, the negative or the positive?
The negative.
The negative. Okay, so that helps us. So what are the numbers?
-9 and 2.
There you go, -9 and +2. Okay, so there's our numbers. So that tells us how we can split this middle term, right? Okay, so we've got our 3 we've already taken out. Let's go ahead and enclose the rest of this in brackets. And let's go ahead and split this middle term using our magic numbers. It does not matter which one we put. It doesn't make any difference, the order in which we split this thing. No difference at all. I could write this as -9x plus 2x or plus 2x minus 9x. Doesn't matter. Why don't we put the -1 first so we've got a plus sign in the middle? Everybody see that? We okay with that? That's how we split that based on our magic numbers. And now all we have to do is group. Okay, so we can split this into 2 parts. So there's our dividing line. Here's our first group. From our first group, what's our GCF going to be?
3.
Say it again. What's it going to be?
3.
More than just 3.
3x.
There we go, 3x, right? Good, we can factor out a 3x. And what's going to be the binomial factor that remains then? I'm dividing away a 3x, so what am I left with?
2x minus 3.
There you go, 2x minus 3. Okay, so now we're going to have this plus sign in the middle, right? And over here, look what we've got to do. We've got to have a GCF. Well, it doesn't even have to be a GCF. It just has to be a factor out front. And what does our binomial factor have to be? It's got to be 2x minus 3, right? We have to have a common binomial factor. So these two always have to be the same. And so now we can just fill in the blank. What has to be out front then? What times 2x minus 3 is equal to 2x minus 3?
A 1.
Yeah. So we don't even really have to write it, but there's a 1 there, right? And so now look what we can do. We've got 3 times this quantity in the brackets. I'm going to factor out from each of the 2 terms. I've got this common binomial factor that I can just, I can pull this, factor it out front with the 3, right? So I end up with, out front now, I've got my 3 times the quantity 2x minus 3. And what's left behind in my brackets? Well, I've got my 3x plus 1, right? And I don't need brackets anymore. So now I can just write my answer down. My answer looks like 3 times the quantity 2x minus 3 times the quantity 3x plus 1. Okay, make sense? Okay, let's do another one. You guys want to take a second and try that on your own, then we'll go through it together? Let me know in chat when you're done. Okay, what can we do first here? Type it in chat. Everybody answer. What can we do? What should we do first? Okay, good. Factor out the greatest common factor of 4x. Perfect. So we're just going to do this, right? We're going to factor out a 4x, which leaves us with what? 4x times what is 8x cubed? Well, that would be a 2x squared, right? 4x times what is 68x squared? Well, that would be a 17x. And 4x times what is 56x? Well, that would be 14, right? Okay. So now we're left with, we got a GCF, and then we've got an irreducible, we got a quadratic trinomial, right, that we've got to factor. Okay. So what do our magic numbers, m and n, have to add to? What is, or multiply to? What's the product of a times c? Type it in chat, everybody. Okay, should be hearing from everybody. Okay, good. So we need factors of 28 that add to b. What's b? Type it in chat quickly. Okay, I'm seeing it, 17. So they multiply to a positive and add to a positive. So m and n are both positive. And what are they? What numbers multiply to 28 and add to 17? Do they exist? Don't exist, do they? There are no numbers that multiply to 28 and add to 17, right? So what's that mean? What's that mean?
It means you can't factor it.
Can't factor it, right? We're done. Okay. So this is our answer right there. That's the best we can do right there. Okay. That's as far as it factors. Okay, let's try another one. I forgot that. I didn't think that was that example. I wouldn't have given you so much time. I thought that was the next one. Sorry. Okay, what about this one? This looks tricky. It's got X's and Y's, but the beauty of factoring by grouping is it doesn't matter. It's going to work just as easily if you have multiple variables here. So is there a GCF I can factor out? No, there's not, is there? Right? Okay, so now let's look at this here. So we need to have, we need factors that are going to multiply to A times C, right? Okay, so what are A and C here? We've got A times C. Oops, oh, there we go. Like in these previous examples, when we've done A times C, I want to show you something. We've always excluded the variables, right? Like, let's go back to one that worked. Like, how about right here? We've always excluded the variables, right? But we just as easily, if we took this example right here, we just as easily, let me take a picture of this, and I want to talk about this. This is kind of a more advanced topic. This is not something that I would necessarily do. Whoops. Oh, here we go. No, I do want that. Yep, never mind. Oh, my goodness. There we go. Okay, look what else we could do here. We could write down we could include the variables, right? I could include the I could include this product to mean with the variables, the product of the two. If I'm going to factor this into something like, eventually it's going to look like this. It's going to look like something like, we're going to get a product down here and a product down here. This has an X, this has an X. I know that when I multiply those variables out in there also, the reason I'm able to ignore the variables is because I know I've only got one variable, right? I know that I'm going to get an X, something times X here and something times X here. When I multiply that out, that's going to give me an X squared for my first term. I'm going to get an X when I FOIL this out. I'm going to get an X, couple of X terms that add up. And then finally, when I add up my numbers over here, when I FOIL it out, I'm going to get a number there. Well, what's going to happen in a case like this that's a little more complicated? It still works, doesn't it? Because look, I'm going to end up, when this thing eventually factors, I'm going to end up with now something like this. I'm going to get some number times X plus some number times Y times some number times X plus some number times Y. Well, when I FOIL that all out, I'm going to get an X squared term. When I distribute this X to that Y, I'm going to get some number times X times Y. When I distribute that Y to that X, I'm going to end up getting some number times X, Y. Those will combine. And then finally, when I distribute this Y over to that Y term, I'm going to end up with some number times Y squared. Right? So the pattern, even though I've got Y's in there, we can see that this is going to factor. It's going to factor in a way where the magic numbers will still work. Does everybody get that? Right? It's okay. So we can pick our magic numbers the same way we did before. This is A, this is B, this is C. right? But when we're all done, when we split this thing apart, I'm just going to have coefficients of x and coefficients of y instead of coefficients of x and constants. But it's still going to work, okay? So what are our magic numbers then? They need to multiply. A times c is just 8 times negative 3, right? So that's just minus 24. What's b? Well, b is negative 2. So they've got to multiply to negative 24 and add to negative 2. So what are our values then of m and n, our magic numbers? They're multiplying to a negative and adding to a negative, so the negative must be the bigger of the two. What are they? Negative 6, there you go, good. Negative 6 and positive 4. Okay, so then we can take this middle term and we can split that up using our magic numbers. Now watch, this is still going to work. I'm going to get 8x squared. Doesn't matter the order in which I do these. Let's do minus 6xy plus 4xy. So I split that middle term with my magic numbers, minus 3y squared. And now I can just break this down the middle. I've got two groups of 2. Okay, what's my GCF from the first group here? 2x. Okay, so I've got a GCF here of 2x. And what's my binomial factor, the remaining binomial? If I divide each of these through by 2x, what do I get?
4x minus 3y.
Okay, good. So now I've got my plus sign, and I've got to have the same kind of pattern over here, right? I need to have an identical binomial factor, a common binomial, so that's got to be a 4x minus 3y. Well, what has to get factored out to make that happen? What times 4x is 4xy? Y, right? And if I distribute that, it works, doesn't it? If I distribute the y, I'm going to get 4xy minus 3y squared. Everybody see that? So now I've got my common binomial that I can factor out of each of my two groups or two terms. And what's left behind when I do that? From the first term, what's left over? Okay, I'm seeing it. People are signing it 2x, right? So I get a 2x plus y. Everybody see that? So my final answer then, there it is. It's factored. 4x minus 3y times 2x plus y. Okay? Everybody see that? So it did work there. Now, why did it work? How come that y worked? Another way of thinking about this is, look, this is symmetrical, isn't it? I've got an x squared and a y squared and an x times y in the middle term, right? So by symmetrical, I mean, I could have flipped this whole thing around and put the y squareds first and the x squared second, and it wouldn't have mattered, right? I still would have had the x's being squared and the y's being squared and the product of x and y in the does everybody see, like, if that had been a y cubed, if I had 8x squared minus 2xy minus 3y cubed, well, it wouldn't have worked, right? Wouldn't have worked, because then it's not symmetrical, right? The product of the exponents here, of the x's and the y's, has to be 2 in each term for this to be truly quadratic. Everybody see that? I've got an x squared times an x to the 1 times a y to the 1. Well, 1 plus 1 is 2 plus a y squared. Because the exponents all add to 2 like that, it has a chance of working if we can find the magic numbers, which we did. Okay, give me a 1 to 5 on that. That's kind of advanced stuff. I mean, that's, I'm throwing that at you. That's not normally an Algebra 2 type question, but okay, good. All right. Let's let's come back to this one if we have time. Okay, I want to show you, just remind you really quick how you can do this using slip and slide, right? This is, and I hate this, but it is quick and easy. And if you like it, it's fine. Just know that it's not rigorous, but it does work. So what do? Well, we're going to slip A to the end of the trinomial and multiply by C, right? So there's our A times C, right? So what's that look like down here then? Step one, we're going to slip the 6 to the end, and that's going to give us x squared plus 13x minus 6 times 28 is what, 168? Factor the new basic trinomial. So we got to find magic numbers that multiply to negative 168 and add to 13. Okay, now let's think about that. If they multiply to negative 168 and add to 13, we know, let's make a column here of possible values of m and n. Okay, we know if they're multiplying to a negative, they're opposites, and they're adding to a positive, so the positive has to be the bigger of the two, right? Everybody agree? How much bigger? How much bigger does the positive have to be if they're adding to 13? 13 bigger, right? So one way you could do this is the way I would choose to do this. I'm just going to pick, rather than trying to find factors of negative 168 that add to 13, I'm just going to pick some values of pairs of numbers, positive and negative, that add to 13 to see if I can get one that multiplies to negative 168. See what I'm saying? To me, that seems a little bit easier. So let's just start with something like, we'll just kind of randomly start somewhere. What if I start with something like positive 18 times negative 5? Everybody agree those add to positive 13. Well, what's that product equal to? We'll make it, that's not nearly big enough, right? That's just negative 90, so I need bigger numbers. So let's skip up a little bit. How about 20 times negative 7? Well, that's negative 140, so we're getting closer, right? So now if we do 21 and negative 8, well, what do you know? We get negative 168. So those are our magic numbers that multiply to negative 168 and add to 13, right? Everybody see that? Give me a thumbs up if that makes sense. Okay. So we're going to, we factor this thing, right? So now step 2, this factors into x plus 21 times x minus 8. So we just factored our basic trinomial. Okay, now step 3, we're going to divide both of the magic numbers that by the value that we slipped, which was 6, right? Which was a. So step 3, we end up with x plus 21 over 6 times x minus 8 over 6, okay? And now the final step is we're going to reduce the fractions and slide the denominator back out front, okay? So we can reduce 21/6 to, what's that going to be, 7 halves? And we can reduce 8/6 to 4/3. And then all we have to do for that final step here, when we slide the denominators up to the next variable, up to the coefficients of x, we're going to slide the 2 up front, we're going to slide the 3 up front, and so we get the answer 3x plus 7 times 3x minus 4. Okay? Can you guys kind of see in there that you're doing all the same arithmetic that you do normally? It's just a different sequence of steps, right? But you see what I don't like about this? What I don't like about this is our original expression is not equal to that, right? So we're taking an algebraic step there where we have two non-equivalent algebraic expressions that we're trading for one another, and that just kind of rubs me the wrong way mathematically. But it works. I mean, you could consider this kind of side work and do this on the side of your work just to factor the thing if you wanted to, where we did all this work on the side, and then we just set this equal to this factored expression once we did all the work, where we resume our algebraic train of steps, right? To kind of make it side work, just like you're doing some arithmetic. It's up to you. If you really want to use that, you're welcome to. Okay. Here, notice that there's a little bit of a problem here, though, right? Here, this doesn't work as well, does it? Right? It's harder to do slip and slide. It's harder to think about how to do slip and slide if you're involving both X's and Y's. Right? It's pretty difficult to, I mean, it still technically does work, but it's just a little more awkward. If we want to try to do this one, like step one here, I've got to slip the 6 to the back, right? So that creates the expression x squared minus xy minus 12y squared. And that's still a little bit awkward, isn't it? Right? Everybody see that? I mean, we could make it work. If I wanted to factor this, it's a little bit harder. I know I'm going to have factors that look like x, but what are the numbers that are going to go with y here? They have to multiply to negative 12 and add to negative 1. So it'd be like negative 4y and positive 3y. And now what, right? Now I'm going to divide each of those by 6. Reduce the fractions. And then slide the denominators up front. And so I end up getting okay, and we could check it by just multiplying it out, but that's going to work. But to me, that's harder to, that's less intuitive than doing it by, like, look at the way we did this. Look at the way we did this guy right here. To me, that's much more intuitive to think about it that way. It just each step makes more sense and seems more logical when you're using grouping with multiple variables like that than if we're having to use slip and slide. But I'm okay. Whichever way you really want to do it is okay. When you're doing work on the test, I don't care. You can take your pick. Okay? Questions? Does that all make sense? Okay? Good. How much time we got? Oh, not much. Gosh, I wanted to do kind of a little trick for you, but I don't think I have time. I'll save it for Monday. Kind of a fun little math trick, but it takes a little more time than we got. So, all right. Well, I'll tell you what, I'm going to let you folks go a couple minutes early. Then you can get up and stretch, get a quick snack before advisory. Sound good? I'll be here after school if you need any help. You've got the assignments up there. How are we doing on the assignment? Anybody done with the assignment? The factoring assignment? Have you seen it? Should be. Let me make sure it's up there. Should be up there. Let me double check, though. I'd hate to have you guys go into the weekend and have that thing not be up there. It wouldn't be the first time I've done that. I haven't put it in here yet, so I need to do that. I'll add the current week and put it in here, but if you go into Math Excel, I'm sure hoping it shows up here, does it? Okay, oh my gosh. This thing it messes me up sometimes. I think I have these things up there and then they're not. What's going on? Okay, these are all set. These were supposed to auto, I don't know why they didn't work. I had them all set up so they were supposed to automatically become available, and it didn't work. But if you go to homework and tests, you'll see now that they're showing up. The H.4.1 practice 1, H.4.1 practice 2. They were supposed to be staggered, so the first one was supposed to be start up a little bit earlier, but I'll just make them both due on. They're just factoring practice. I'll make them both due Monday. One will be due at the start of class, and one you could have it won't be due until that evening. And once again, the due date. It's not like the due dates they're just recommendations. You're not going to miss any credit if you don't get them in on time, but that'll get you going. And I'll put them on Google Classroom. Does that make sense? So you got these two little assignments. First one's over GCF, factoring out greatest common factors and difference of squares. And then the second one is over factoring trinomials. Okay? Perfect. Have a great weekend if I don't see you before Monday. And I will talk to you soon. Bye.